So I'm going to talk to you, and I think leading on from lots of the conversations that's happened today around, why digital twin? Why would we look at this? Why are we interested in this? And what are the outcomes and the business values that having a digital twin can deliver? We've been talking a lot about, in the construction industry, about building information modeling. This isn't about building information modeling, which is a process. This is about actually capturing data, as the guys just said, making that data visual and then being able to use it not just in design and construction, but through into the operations phase and then back into design, as we'll show today. So, no presentation would be complete without some stats. So we know that organizations use a huge amount of space, okay? So this is a US stat, maybe a couple of years old now, but 12 billion square feet of space just in the US is used. And we all know everybody touches a building every single day, whether it's where we live, where we play, where we eat, where we work, where we get better. So buildings are really, really important. The keynote this morning was on about cars as well. I think transport and buildings, they go hand in hand, really. And this space is really, really expensive. So in IBM, we talk to our clients a huge amount about how much they're spending on their space. Have they got the right amount of space? Is it right size for their company today and tomorrow? They may need more space, they may need less space, but how do you predict that and understand it? Because it is normally the second biggest cost after your employees, which are forgotten a lot of time in terms of space, but it is a big expense and a big cost for people. So how do we keep on top of that? And then, as said, my stats 50%, but 47, 50%, huge amount of space goes underutilized. Now, if you work in IBM and you work in South Bank, this is like it's fully baked the whole time, that building. But that's a one-off. Most times it's very, very underutilized. And then we have the empowered generation. If we have kids, we all know that our kids are very, very IT and tech savvy these days. And I think this moment in time, this period in time, we actually go to work for the best. We don't no longer go to work for the best technology. We have that technology at home, in our homes, and we bring that to work with us because the buildings and the places where we work generally are just not up to it in terms of technology. So how do we have our space so that it is useful for people to use, that people want to come into that space? And it's been spoken about a lot. We are gathering data the whole time while we're in these buildings, be it on our handheld devices, be it through IoT sensors, whatever. So how do we utilize all of this information? And, get it right, get space right. It's not just about rocking up, opening your laptop and working. It's much more than that now. It's about developing communities within the workplace. It's about having the social element. We are social creatures. I was at a talk last week and one of the presenters said, the worst thing that you can do to a human being is put them into solitary confinement. That's the ultimate punishment, right? So we want to be together, we're gregarious, we work well together, we team together. So how do we make sure that our spaces are fit for purpose? Because I am of the opinion that, we've put up for a long time with space in the workplace. We've kind of just dealt with it, moaned about it, but we've still carried on coming. We're on the tip now of this is going to change, definitely. It's a no-brainer, really. I don't even know why I have this slide in here, to be honest, because obviously if you can optimize your space and make it useful and make people want to be in there, make people productive or help people to be productive, you are going to save millions. You could probably generate millions. And it results in better employee engagement. And if your employees are engaged, then obviously they're doing a great job for you. Because if somebody is moaning about it's too hot, it's too cold, it's too dark, it's too light, it's too noisy, then guess what? They're not concentrating on what they're paid or what we're paid or what we're tasked to do because we're too busy thinking about this other stuff. So therefore, we're not productive. So the digital twin. So, kind of a definition, it's a virtual representation of a physical object or system, and this is absolutely key, across its life cycle. Other industries outside of construction and the built environment have been doing this for donkey's years, okay? So it's across the life cycle, design, build, and operate. And we use this historical and real-time operational data and other sources to enable us to understand, learn, and reason, and then dynamically recalibrate for improved decision-making. right? It's a no-brainer. They do it, cars, aeroplanes, watches, phones. Everybody does this the whole time, right? Why are we not doing it in the built environment? And then once you have this, there's a whole plethora and a whole playground and sandbox and money to be made in digital twin services right across this whole life cycle. So it's not one player. I'm not standing up here saying IBM does it all. No, we do not, right? We are part of a huge ecosystem that can enable this and make this happen. Motivation here. Why should we do this? Like 2007, right? The Toyota Camry. Look at the amount of partners and people that make that car happen, that add value into that car. It's not Toyota by themselves. It's a whole ecosystem of partners that come together to make that car something that, probably, not as enjoyable to drive now in 2019, but 12 years ago, this is what was happening in the automotive industry. People coming together and making this car valuable and something that we can sell. So a new way of thinking, not really, okay? So if you look at this example here about airlines, right? People who manufacture aeroplanes. So there's a specific design, right? An aircraft design that is based on what their clients want, their clients' preferences, okay? So they understand the design and the requirements. So guess what? You have to manage those requirements. You have to understand what each and every one of those requirements are. They have to be concise, achievable, deliverable. When you do that, then you have a faster time to market. You get it right the first time, and you get a better customer experience. Okay? So we've got that. Now we need to build it. Where are we going to build it, right? We're not going to go out in a field and build it, right? We're going to build it in a manufacturing environment so it's controlled. Okay, we can do manufacturing assembly, very controlled, following the design requirements and keeping on top of the design requirements and understanding are these requirements good. We can, if we do this based on a digital twin, we've got improved planning. We can be flexible without charging. We can be agile. We can have an informed supply chain, leaner production, because this is where a lot of the savings are made in construction is just by being lean, okay? Lean construction. Don't do the same job 4 or 5 times, having 10 people do one task. Seamless testing and certification. And then this is, for me, where I like to focus, operate. Okay, so this aircraft is monitored in service all the time. We know this, right? We know it's kind of power by the hour, etc. We know all the sensors. We know when the aircraft lands that the tech team are there, if it's a known fault, fixing that, ready for the next flight. But all of this goes back and forms design. And also we're taking real-time feeds from people as well. Are people enjoying their experience? Is this good? We've all got a mobile device. Most people tweet. Unstructured data can be used as part of this design process. How do people feel about this? The touchy-feely side of the house, But the sensors are providing information that enable upgrades, that enable, is the design working? So we have experience in IBM, and I won't say which building it is, but we lease a building, and architecturally it's gorgeous. It looks fantastic. Floor-to-ceiling windows, really nice, airy, bright space. But guess what? As soon as the sun comes out, if you're in a room that's 3 walls of glass floor to ceiling and chilled beams are cooling that building down, it's a little bit hot, right? So doesn't work, right? So yes, aesthetically it's fantastic, but actually using this space doesn't work. So who's telling the designer that? Who's telling the architect this? Nobody. We're just sitting there moaning, oh, it's too hot, open the window, close the window, So it has to be this loop back again. And forgive me, I've turned this on its side a little bit. So we do a lot of enterprise design thinking. And in the built environment, currently we ideate and then we make. And then we go over here, we ideate and we make. And very little shared experiences. We don't sit and observe and then reflect and then make. So we don't understand what's going on in the operations phase of a building. People do. Like CBRE do, JLL do, the people managing the building, they kind of understand. But where is that data going? It's not feeding back into this loop of design so that we can really get it right going forward. And, I'm lending this example from a colleague here. So if you look at this truck, if you look at Digital Twin version 1.0, it's about IoT driving instrumentation of the many assets within and we can apply this to buildings. We know there is IoT, sensors. All of the equipment in a building now is smart equipment. So your HVAC systems, your lighting systems, they all come with sensors. It's all really smart. So let's take that and start to monitor performance in real time. Then building up on that, then we need to integrate the solutions. Okay, so we need to have integrate the tools from the various life cycle stages so we can start to build on this and really make use of all this data that we have. Then building up even further, then we can start to do to be context sensitive and deliver the AI. So in real time, we can really learn what is going on, and we can bring in outside parameters like the weather and things like this. So really understand how a building is operating, and then make those informed decisions. So basically, the requirements for a digital twin is to be able to capture the domain knowledge. Is to be able to learn from operational data from the in-use. And then it's for that data to be able to be used by the experts to have informed decision-making so that they can make change. And so if you want to do AI, the essential components then are having semantic models and reasoning so that you can understand how these systems are all connected together. Then automated machine learning, it's come up a few times, right? How much data is being generated. We can't use traditional methods anymore to analyze this data. There's not enough of us, there's not enough time. You know, we need to start to automate this, but you've got to do that on trusted data, obviously. And then there's no point doing all of this if people can't use it. So then bringing in the kind of VR, the visualizations, how do we have a natural augmenting interfaces into this data that's reasonable for us to use, that helps us do our job, make us much more effective and deliver good products at the end. So, you know, if you look at the need for AI, so, you know, AI leads to huge amounts of data. But if you think about our screens and our devices, they're getting smaller and smaller. So as we move in, you know, as the screens are decreasing, we need more AI, right? Because we need to have data pushed to us that's valuable, that we don't have to go click, 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 searching for the whole time. So we really need to look into this as well. And so, you know, if we bring in the design and construction, huge amount of talk in the construction world on those 6 months to 5 year period. You know, how do we get this right? Using BIM, 3D modeling, you know, there's lots of talk, lots of disruption going on. But we forget about the next 20, 40, 60, 100 years. That's where the money's spent. That's the operational costs, where loads of money is spent. So let's use the data that's generated and not regenerate it every 5 years. Let's use it, keep it up to date, keep it relevant so that it can be part of the sale of a building. It becomes together. You know, it's almost like I'd love to hear language of, you know, okay, here's the building, and somebody say, okay, well, tell me about this building. You know, tell me how much it costs. Exactly how much it costs. Tell me who painted that wall. Tell me who fit that carpet and when it was last replaced. And not somebody have to go and look on spreadsheets, but click into the model. There you go, that carpet was laid by X in January, I don't know, 2012. Right, all this information. This is the supply, this is how much it costs. You know, it's due for a refurbishment in 6 months' time. All this relevant information that comes from what the design was, who did the original work, right through to the operate and the change and the refresh and the modernization phase. And, you know, the last speaker brought this up as well about how much data exists. We've been collecting data in buildings for ages, right? It comes with the automation of buildings. You know, starting to talk to pieces of equipment, turn on, turn off. Brilliant, really great. Little database of data there. Then with the smart building era, where we were bringing in fault detection diagnosis, we were talking to the assets, we were pulling data via the BMS systems, really making great ways into reducing costs, understanding when things, you know, what types of failures were happening, reducing planned maintenance times, reducing reactive maintenance. In this cognitive era with all this IoT, we can't use these traditional methods anymore. We have to use AI. We have to go and use machine learning and AI because we will just drown in this data otherwise, and it will go unused. And so if we look at AI, you know, where we are today, we're just past the narrow AI with the emerging technologies. You know, we're specializing on very specific problems. And my colleagues, you know, they believe that, you know, it's going to take us a good few years to get to this revolutionary general AI, but it is coming down the track where it's autonomous intelligence that enables you to solve problems, okay? And so, with AI and analytics and IoT, we can start to gain these greater efficiencies. We can really start to look at every system, every part of the building, and really understand how that's operating and where we can save money. Sorry. And so, you might be thinking, gosh, how is this achieved, right? So it's not a sales pitch, sorry, it's just some IBM products in there. But if you kind of look at that middle layer, what are we talking about here? So we're talking about open services for lifecycle collaboration. So this is managing our requirements, understanding what works, getting rid of language that doesn't make sense to anybody. Then the machine learning, so understanding, do the requirements fit? Is there any gaps we can find? Semantic discovery, conversation generation, so making it fun, having assistants, virtual assistants that, some partners of ours have these holograms that you can converse with, and they tell jokes, things like this, to make it fun. Workflow optimization. What we haven't touched on, actually, a lot is business processes, right? So there's no point having all this tech, doing all these things if you don't change the way you do things, right? So you've got to look at your business processes. A great example of this is I know of a situation where somebody put smart bins in their offices, and they said, I wouldn't do that again because the cleaner just comes and empties the bins anyway. Well, that for me is a perfect example of not changing your business processes, of not saying, okay, this is the way we do this now. You don't empty that bin until you get an alert on your mobile device. So really simple example, but we really have to look at this, else none of this will work. If we carry on doing things and try and shoehorn the tech in and don't change the way we do things. And then provenance as well, so the hyperledger, so we can make these, there's lots of talk around how do you share data, securely, safely, so you don't risk your IP. There's lots and lots of ways we can do that as well. And then underneath that, you've got your digital twin knowledge graph, and then you've got your message hub, and then all the integration pieces in and out of this. So, third parties, so people can come in and be part of this. And so, we've got all these IoT systems, we've got your digital twin, they've got all this analytical fog, and it isn't just about one cloud platform or one database. This is an ecosystem, right? And it's about how you pull all of these together so that we can get over this, I think this might be a Cisco phrase, this analytical fog, so that we can do the analysis and get the outcomes that people need. And so, digital twin as an enabler for AI. So, when you've got your simple twins, you're just integrating, you plug and play, you've got some kind of data service and integration. Then we're moving up into really understanding and learning what's going on within the building in this case. Then once we understand historically what's going on and what's going on today, then we can start to predict and optimize. And really start to say, okay, in the next 48 hours, this is going to happen. So you've got a window of chance to change things. Then, as we build up into the more fully mature twins, we can start to automate these processes. And that gets people a little bit scared there. But we can start to automate things and really, let people do interesting work instead of boring work. And then you're into artificial intelligence, where you could have a building that starts making its own decisions. Okay, based on the data that it has available to it. So, it decides that it's going to pre-cool the building at 4 a.m. because it knows the price of the energy, it knows what the weather's going to be, it knows how many people are going to come in, just makes that decision. You kind of go, yeah, well, maybe you could do that through the BMS today. Well, no, because it'll be time-based, it'll be 4 a.m. every morning, or somebody's got to change it, but dynamically the building making this decision. And so what are the outcomes, really, for this? Why bother? And I loved the panel earlier that was saying, we really focus in on the business outcomes. It's got to be about the business outcomes, else it's just a nice conversation or a fun conversation. So, in terms of the buildings themselves, make it cheaper. Make them come in on time, on budget. Faster time. Get these buildings up and running. Have personalized spaces. Think about the people in the building. Make it personal to them. So you're assigned a desk that, fits best the way you work. Have these enhanced experiences. There's lots of reports out there that in a retail situation, if customers walk into a store and they have exactly the same products, exactly the same layout, customers who touch technology during the time in that store feel they have a better experience than people that don't. So it's human, right? We want this technical experience. Then we get this autonomous control. We've got the real-time knowledge of the full life cycle costs. So that for me would be great. You know, when you're putting out, there's loads of use cases here, but when you want somebody to provide FM services, you can tell them exactly how much it costs to manage this building on your behalf. Brilliant. Then you've got well-being, obviously, we can't forget wellness, and then increased profits, hopefully, is basically why we're all sitting here today. Thank you.